Okay, so basically here's where we're at, right? So what we want to do is take something of the general form and we want to convert it to the standard form because that is an easier form to graph and to do information with. Now the A we know to be pretty easy, right? A is whatever the leading coefficient is. So it's the vertex that's a little tough. So how do we find H and how do we find K? And what we've learned so far is we can do that by doing a modified completing the square process, and that gets the trick done. However, as we also saw in a couple examples, it's a little lengthy, it's a little crazy on the math. So is there an easier way? And the answer to that is yes. All right, and so it's going to be very similar to what we did in the buildup of the quadratic formula. We're going to basically take, oops, I shouldn't have that equal to 0. We're going to take a general equation and we're going to complete the square on that and then take a look at what we have and compare and contrast with our H and our K. So again, in the process, in our modified completing the square, the first step was to throw some parentheses around the two terms that represent the incomplete square, the variable stuff. The next piece was to factor out the A. And when I do that, I'm doing a couple of divisions, right? So A divided by A is 1, B divided by A is just B over A. And of course, you can always check yourself by redistributing. Next idea was to take whatever this number is here and take half of it. So B over A divided by 2 turns into B over A times 1/2, which turns into B over 2A. So again, that part's important. It's going to help us factor later. But what we need to do with it now is to square it. And what we get is B squared all over 4A squared. So there's the piece, right? That's the part that completes the square. So I'm going to come back over here. And to complete the square, I'm going to add it. But to balance that off, I'm going to subtract it. Alright, so again, there's our balancing act. The next move is this minus part we want to bounce out of the parentheses. So it's being multiplied by A. So be careful because when I bounce it out of the parentheses, alright, we're going to get a minus, and then we're multiplying by A, and I have an A squared down the denominator. So we get a B squared all over 4A, and then plus C. Okay, so there's basically what we have. This piece right here factors. So it factors as x plus b over 2a squared. And over here, what I can pretty much do is find a common denominator. And in this case, I would multiply both top and bottom by 4a. And rearranging things, we basically get 4ac, right, minus b squared all over 4a. Alright, so there we have it. And if we take a look at what we want, right, so here's the form. And so if we match things up, we can basically see, a is still a. And then right here we have an addition sign, but we want a subtraction. So that just basically tells us that h is negative b over 2a. And then it's a little more complicated, but k is basically 4ac minus b squared all over 4a. Alright, and so there's your formula. So we now have ways to find h and to find k by just using our a, b's, and c's from the general form. Now, one last thing that I would like to do is this is very hard to remember. This isn't too bad, but this gets a little hard. And so another way to find k is to use the fact that we're talking about a function, right? A function is an input-output system, and this is the x-coordinate of our vertex. So to find the y-coordinate of our vertex, you can use that formula if you want, but you could also consider, well, what's f of h, right? So take whatever you got for h here, that's your x-coordinate. To find the corresponding y-coordinate, just basically plug in the h that you got here. Now that's the way that I prefer to remember the vertex formula. like that. But if you want to remember that for k, you could do that as well. So you're going to see me do this, but if you want to use that for k, knock yourself out. What we have is a formula to do this. So in practice then, here's an example. I've got, that's a 3 there. So f of x equals 3x squared plus 12x plus 7. And so in this case, a is 3, b is 12, and c is 7. So how do I find my vertex? Well, with my formula, I know that h is negative b over 2a. So plugging in what I know, this is negative 12 times 2 times 3. And so that's negative 12 times 6. What we get is negative 2. So h is negative 2. All right, how do I find my k? Well, again, if you're crazy, you can use that. All right, but I'd rather just say, well, k is whatever my function value at that x coordinate. So I'm just going to evaluate a function. And I think we get 3 times 4 here. That's a negative 24 plus 7. We get a 12 minus 24 plus 7. That's a negative 12 plus 7, and we get negative 5. So k is negative 5. So the vertex is at the point negative 2, negative 5. And as a reminder, this is what we did when we first started this venture. We actually completed the square on this same polynomial, and we ended up getting the same exact situation. So there's another way. Obviously, it's a shorter way. It's a nice formula way, and you can avoid doing all this crazy math to find our vertex. And of course, now that I have the vertex, right, this is going to be 3x minus h squared, right, plus k. And that just turns into 3x plus 2 squared minus 5. And so there would basically be our standard form with our vertex, basically using our vertex formula. So again, there's the formula. This is the way I like to think about it. But if you want to work out your k that way, you can as well. Like I said, you decide as you do your homework. And there you go. So let's go practice this vertex formula.